Chapter 9, Section 4, Geometry's Most Elegant Theorem. Elegant, oh, das ist Fantasie. It's my Einstein imitation. Hopefully you enjoyed that. Let's go. Theorem 69, the square of the measure of the hypotenuse of a right triangle is equal to the sums of the squares of the measurements of the legs. So if triangle ABC is a right triangle with right angle C, then A squared plus B squared equals C squared. And we know that as the Pythagorean theorem. So we also have another theorem off that, which is if the square of the measure of one side of a triangle equals the sum of the squares of the measures of the other two sides, then the angle opposite the longest side is a right angle. And that's the converse of the Pythagorean theorem. In our drawing here, if a squared plus b squared equals c squared, then triangle ABC is a right triangle. So you can prove right triangles using the Pythagorean theorem. Okay, so Pythagorean triples. So a Pythagorean triple is just a set of non-zero whole numbers. Whole numbers, remember 1, 2, 3, 4, 5, etc. and onward. Okay. I don't know why they include whole numbers in this definition, because if it's got a side of 0, it doesn't exist. So let's rephrase that and just call these natural numbers. So A, B, and C, any natural number, which are the counting numbers, such that A squared plus B squared equals C squared. Those are called Pythagorean. And here are some common ones. So the top of the column that you'll see here is basically the base of what we call these Pythagorean triples: 3, 4, 5s, 5, 12, 13, 8, 15, 17, 7, 24, 25. Now, the bottom part here, where I'll put this in a little different color, but this part down here, these are the ratios. So if you can reduce any of the sides to these common ratios, 3 to 4 to 5, 5 to 12 to 13, 8 to 15 to 17, 7 to 24 to 25. You have a Pythagorean triple, which means that you have a right triangle. And this saves some time and effort in taking quizzes and tests, things like the ACT and the SAT next year when you're a junior. This will come in very handy then. So Pythagorean inequality theorems, right? You're used to the Pythagorean theorem says, hey, I've got a right triangle. Now, if the square of the lengths of the longest side of a triangle is less than the sum of the squares of the lengths of the other two sides, then the triangle is acute. So if a squared plus b squared is greater than c squared, then triangle ABC is an acute angle. Derive the next part, which says if the square of the length of the longest side of a triangle is more than the sum of the squares of the lengths of the other sides, then the triangle is an obtuse triangle. So if a squared plus b squared is less than c squared, then triangle ABC is an obtuse triangle. Insert awesome Pythagorean theorem example problems here. All right, let's do it. All right, we want to solve for x here. Now, the first thing I always do when I do this, I'm gonna do it long way, and we'll do it, and then we'll figure it out. I'll show you a little shortcut. So it's gonna be 6 squared plus 8 squared equals x squared, and you end up with 36 plus 64 equals x squared, which is 100 plus x squared, and we're gonna take the square root of each side of this, and that ends up being x is equal to 10, right? So here's a little quicker way of looking at this. I look at these two values here, and I see those are the legs, and I see the common factor of 2 with that. So I can divide 2 out of each of these, and I get 3 and 4. So this makes this a 3, 4, 5 right triangle, which means that if I multiply each of those by 2, then 5 times 2 gives me 10. That's another way of approaching this problem. Find the perimeter of the rectangle shown. Well, this, of course, can we do a Pythagorean triple? Yeah, but let's do it longhand just so we can do a little practice in here. So we got 5 squared plus x squared equals 13 squared. So 25 plus x squared will equal 169. X squared equals 144. So lo and behold, x is equal to 12. So this is 12, this is 5, and this is 12. So the total distance around is 34 perimeter, right? Now, again, you could have recognized this and said, well, that's a 5, 12, 13, and saved yourself a whole lot of time. Remember, knowing those Pythagorean triples, you're going to have, if you want to learn them, they're not hard. 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25. You just, work with it enough times, you'll be able to rattle them off. So now, find the perimeter of a rhombus with diagonals of 6 and 10. So, here is a common mistake that people sometimes make. They say, well, this is 5, this is 3, this has got to be 4. This cannot be 4. This is not going to be 4, and here's why. That's the hypotenuse. The hypotenuse must be the longest side, and 4 is not more than 5. So it's not a triple. So now we've got to go and do some algebra. So 3 squared plus 5 squared equals x squared. So 9 plus 25 equals x squared. So 34 is equal to x squared. So from here, we're going to take the square root of each side. And we end up with x is equal to the square root of 34. That's your answer. So what's the perimeter? Well, in this case, we really can't do anything to simplify the square root of 34. The factors of 34 are 2 and 17, both prime numbers, so we can't do any further work with that. So what we can just write is this. The perimeter is equal to 4 times the square root of 34. How do you like that? Nice. Oh, I got ink in here. Look at this. Forgot about this. Remember that the diagonals of a rhombus are perpendicular bisectors of each other. Okay, Nadia skipped 3 miles north and then 2 miles east and then 4 miles, or is that meters? That's meters. Wow, that kid was skipping a long way there for me. All right, let's go up 3 meters north, 2 meters east, 4 meters north, 13 meters east, and 1 meter north. How far is Nadia from where she started? Well, hint, we need to draw a diagram. So we end up with, here is a right triangle. And it's 8 and 15 are the two legs of the right triangle. X is the hypotenuse. So is that a Pythagorean triple? Take a moment, think about it. Think. 8, 15, 17. Yes, it's a Pythagorean triple. So I don't even have to play around with solving. But basically, x would be equal to 17. I keep forgetting I have more ink on this stuff. There we go. Since that is started at S and at E, we're looking for the hypotenuse of triangle SAE. She's got a total of 8 meters north of 15 east. Yes, yes, yes. All right, so there's our diagram. And let's do a little thinking now. So we know this whole thing is on the bottom here is 30. Right? We can see that there. And this length here is 20. So I know that this length here and this length here have to be equal. And divide the 10 remaining. So this length is 5, and this length is 5. And then this length inside of here from E to D is 20, as it says. So I've got to find now the altitudes. So I could just pick one or the other, and I'm just going to work here with this one here, x. So if this is 5, so x squared plus 5 squared equals 10 squared, right? 10's the hypotenuse. So let's go ahead and continue. X squared plus 25 equals 100. Therefore, x squared is equal to 75. Again, we're going to take the square root of each side of the equation. And I get x is equal to the square root of 75, which is equal to the square root of 25 times the square root of 3. So my final answer is x is equal to 5 square root of 3. All right, so what kind of triangle do we have here? Is it a right triangle, obtuse, acute? Well, how do we do this? Again, this is the inequality theorem, Pythagorean inequality theorems, right? So if they're equal, a squared plus b squared equals c squared, then the triangle is a right triangle. If they're not equal, right, if it's greater than, then it's acute. A squared plus b squared is greater than c squared, then the triangle is acute. If a squared plus b squared is less than c squared, then the triangle is obtuse. So what do? Well, this triangle is drawn very poorly. We should have the longest side across from the largest angle, and technically it is. So we know that, and this is just designed to mess with you sometimes. The drawings, I don't like that, so I don't do that to you. But I would have is 5 squared plus 7 squared, and I put a question mark here because we don't know what that relationship is, and 8 squared. Okay, so 5 squared is 25 plus 49, and this is 64. And 25 plus 49 is 74, so 74 is greater than 64. Well, if the a squared plus b squared is greater than the hypotenuse, or the longest leg squared, it is an acute triangle.
That's all, folks.
Coming in the final stretch, boys.